Hello, ladies and gentlemen of the internet. Today, let's do something fun. I just did those web filtering videos, and those weren't as fun. So let's do something fun. Today, we're going to do dynamic LAN-to-LAN VPNs, where we can have one ASA act as our hub and have remote ASAs with dynamically assigned IP addresses, build tunnels back to the hub, and then we'll also set it up so there's spoke-to-spoke communication, sort of. So the spoke-to-spoke communication still has to go through the hub, so it's very much a hub-spoke architecture, but you can have ASA, the LAN over on ASA 2 can talk to the LAN over on ASA 3, it just has to route through the hub to get there. So, I mean, it's a super simple diagram, and we'll go through it really quick. We have ASA1 is going to be our hub. It has a static IP of 200.1.1.1. And then we have ASA2 will be our first spoke. It has a DHCP assigned WAN address. We have ASA3, which is going to be our third spoke, also has a DHCP assigned WAN address. And then the LANs are .1 for hub, .2 for ASA2, and .3 for ASA3. And I also have some hosts, little VPCs that we can test with to ping across and make sure everything is working. So we'll go through some of the little caveats as we config, but let's just dive right into it. So we'll start on ASA1, which is going to be our hub. And I'm also just going to get a notepad up because we're going to need that momentarily. Alright, so let's get going. We're going to go into global config. This works with IKE v1 or IKE v2. I'm going to do IKE v2 because, frankly, I need the practice. There's not much on here right now. You can see we just have our IPs assigned, super basic NAT. That way I can work with the no NAT stuff, and well, we'll talk about that. But let's get into our config. So we're going to do crypto IKE v2, helps if you spell it right, policy, and we'll do policy 10. I'm going to do encryption of AES. We'll go with AES 256, and we'll do our integrity with 512. Let's get crazy with it. We're not really passing any real traffic over this. Let's set a lifetime in seconds of something. 2800. Why not? Actually, let's do 2880. Or 28,800, right? We'll enable IKE v2 on the outside interface. Enable on outside. And I'm going to be copying this in the notepad as we go. Just stuff that is universal in this. Like this will be on everybody. We'll set up a transform set. PSEC IKE v2 proposal, rather, what we call it. IPsec proposal. There we go. And we'll call it AES 256, and we're going to say that our protocol ESP, the encryption is AES 256, and we'll do protocol ESP integrity. We'll do the same SHA-512 that we did for our IKE v2 policy. I'll probably do a separate video where we cover GCM and GMAC, but not in this video. We're going to keep it really simple and straight to the point. We'll do a show run crypto IPsec. This guy is going to go everywhere. Let's do crypto IPsec IKE v2. Let's do security association. Lifetime in seconds. We'll do 3600 seconds. Nice and short security association. Awesome. Okay, so on our hub, we're going to set up a dynamic map. So we'll do crypto dynamic map. That's IPsec. Oop, I think I put the name in there first. So crypto dynamic map, we'll call it dynamic S2S. We'll do sequence number 1 for our dynamic map, and we'll set IKE v2 IPsec proposal to be the AES 256 we already set up. We'll also do set PFS, and this is a big one for getting the hub and spoke functionality working, where these spokes can talk to each other through the hub. We're going to do set reverse route. We do that on the dynamic map, not on the actual crypto map. All right, so that's actually all we need on the dynamic map. We'll take a look at the total config here. Show run crypto dynamic map. Just those 3 lines, super simple. And then on the crypto map, we'll call it VPN map. We'll do 65,535. And this is IPsec ISACamp dynamic, and then the name dynamic S2S. And that's all we need on the crypto map, except for tying it to the outside interface. Okay, now we're going to do tunnel group. You have to use the name default L2L group for this. So this is the downside when all of your spokes are going to be dynamic, or when some of your spokes are dynamic. The dynamic spokes all have to use the same pre-shared key. Kind of a bummer, but I'll take a quick second to pull my soapbox out and say that I actually don't like using ASAs for site-to-site VPN. I think it works really good if you're doing like a business-to-business setup. So you're doing a site-to-site VPN with a partner, but if it's for everyone's in the same organization and this is just remote access, or this is just WAN connectivity to some of your remote sites, I actually prefer using iOS, just for the record. Everyone has their preference, but I'll put my soapbox away. So anyway, with that, we have to use, inside of this tunnel group, we're going to have to use the same pre-shared keys for both spokes. And this is IKE v2, so we have our local and remote. I'm going to do it symmetrical, so they're the same key. So we have tunnel group default L2L, and we're going to do IPsec attributes. Notice you don't have to do the tunnel group default L2L group type IPsec and all that crap. You just go right into the IPsec attributes, and we'll do IKE v2 local authentication is pre-shared key and super strong, really secure password of Cisco 123. No one will ever guess that. And then we'll do our remote authentication to be the same password. And I mean, that's really it. I mean, you can do stuff where we can set up a group policy and call it default L2L, and we'll say default tunnel, the VPN tunnel protocol, IKE v2. You can do stuff like that and tie your filter maps and tie your filters on there and all that stuff. For this video, we're not going to do that, but I will set up the group policy and tie it to the tunnel before everything comes up anyway, and just have it there in case I want to do anything in the future, which I won't, because I'm going to shut this lab down as soon as the video is over. So default group policy, we just set it up as default L2L, and all it did was specify the tunnel protocol as IKE v2. And that's it. That's the whole config on the hub, believe it or not. You look at show run crypto map, show run crypto dynamic map, and that's it. Super simple. We don't have to do access lists for matching traffic, anything like that. And actually I lied, because we have NAT, so we have to do our NAT really quick. We'll say object group network, say all sites, and we'll say network 192.168.1.0. You'll see what I'm doing like this in a moment. And 2.0, 3.0. So I have all the subnets in there because since this is the hub, we have to worry about traffic being hitting the no NAT policy we're about to set up for when it's coming from our local hub to the remotes, and when the remotes are connecting to each other and transiting the hub. So our no NAT policies have to match all of that. So we'll say NAT, and it's really any to any. Or any to outside might be, I mean, we can make it a little more specific where it's any to outside. We want to try and catch our inside-outside traffic and our outside-outside traffic. Or you can do multiple NAT policies, but I don't want to do that. So we'll say source is static, and original is all sites, translated is all sites, destination is also static, and original all sites, translated all sites. And speaking of, one more thing on the hub, I keep lying to you guys, we have to do same security traffic permit intra interface because traffic from ASA 2 to 3 will hairpin. All right, so that's it for the hub. All right, so let's go over to ASA 2. We can copy all this stuff. I already have an object group set up for LAN traffic, right? Yeah. Okay, so here's the thing. For this to really work and be seamless, you have to have a single security association that encompasses traffic going to the hub and to your remote spokes. So clean subnetting really helps here. The problem is if you have, let's say like we set our access list up for interesting traffic, right? And we did it the traditional way where we have the first line says traffic from 192.168.2 to 192.168.1 is interesting, and then you did a separate line where it's 192.168.2 to 192.168.3. Then you did the reverse on 3, right? The problem is you'll build this, if you try and ping from a host on ASA2 to 3, what happens is the security association will form to the hub. The hub won't try and build the second end of that communication. It won't try and build the next security association required to finish that communication. So the only way that you can get traffic, the traditional way of doing it like a single, or doing it multiple lines with each subnet defined per line, the only way that you could get that to work is if you send a ping from 2 to 3, and then at 3 you had a host that was trying to talk to 2 at the same time. That way 3 built the same security association to the hub. It's a huge mess, and I feel like I'm probably explaining it wrong, so I'll actually show you the wrong way first. How's that? You can see why it breaks. So let's do it the wrong way first. Let's set up, leave my text editor out. I'll actually steal this and put this on 3 now so I can get rid of it. Alright. So let's set up object groups for network. We'll call it S1. For site 1, we'll say that's 192.168.1.0. And we'll say object group network. I'm doing this the slowest way humanly possible. Hold on. Get rid of that. Be a little bit faster. So we object group network S2 and S3. And we'll say access list. And we'll call the access list L to L VPN, permit IP from object group S2 to object group S1. And then we have a separate line that says from S2 to S3. Okay, and then let's keep that there for now. And we'll just finish our settings. So we'll do the traditional setup on the spokes. By the way, the crypto settings are the same as you're very much familiar with ASA. So we'll do crypto map, VPN map. We'll do entry level. We'll do the entry number as 1. We'll say match address as L to L VPN. We'll do set PFS. We'll do set peer as 200.111. We'll say set IPv2 IPsec proposal, and the proposal was AES 256. Then we just tie that crypto map, VPN map to the outside interface, and we'll do our tunnel group 200.1.1.1. Type is IPsec L to L. Everyone's seen this a million times. IPsec attributes. We'll say the IKV2 local authentication is pre-shared key, and it's Cisco 123. Remote authentication is the same. And I'm just going to steal this bit of config, because that can go on 3. And then I'm going to do more system running config, and we'll begin at tunnel group. And this can stay the same when it goes onto 3. All we have to change on 3 is the source is S3, source is S3, and that second line destination is S2. So again, this is the way that where it's broken, right? That it's less desirable. But I want to show you how frustrating it can be. That way you can feel my pain when I first started labbing this stuff out. So we'll paste all that in. Theoretically, I got it all right. And we should be able to go to our little VPC on 2. Other thing is the hub can't initiate communication because it doesn't have any defined sites yet. Like it doesn't have like a set peer in its crypto map. So you have to initiate traffic from the spokes for this to work. That's another little caveat. So let's try and ping 192.168.1.10. That is a host up on the hub network. We'll give that a second. Not looking great. Probably did something wrong. All right. Let's do this. See what I did wrong. IKV2. We'll do protocol level, and we'll keep it at 1 for now. See what we get. And nothing. It's one of those times you're like, yeah, something shut down. Can I ping my default gateway? Let's do basic stuff. Make me feel like a CCNA. Yeah, I can ping my default gateway. Ah, people at home are laughing. I didn't do no NAT on the hubs, or on the spokes rather. Doggone it. Okay, let's do. Here. I'm actually going to steal the same config from over here. Oh, that's embarrassing. Let's do on all, show run object group, and just steal it. We got all sites. Pop that over there. That's funny. I would forget that while I'm recording. Okay. Boom. And this is actually just inside outside on the spokes. Pop that there. Go ahead and put that on 3 to save frustration for later. Okay, now the ping should work. There we go. All right, so if we come over to ASA1, we can do a show crypto IPsec SA. You'll see we have an SA formed for 192.168.1.0 and 192.168.2.0 as the remote identity. That looks good. We'll go over to 3. We'll try and ping that host. We'll give that a second to stand up. All right, that's working. So now we should have one for 1.0 and 3.0. All right, so that looks good, right? You can even do a show route. Do show route because of reverse route being on the dynamic map. You can see that we have our dynamic entry set up there. That's all looking good. All that works just fine. So here's where things break, right? And this is why you want to have a single security association that encompasses all of your subnets, if at all humanly possible. If I try and ping 192.168.3.10, right? That's the VPC over behind ASA3. You'll notice it just keeps timing out, which is super frustrating. And then if we come over to ASA1, it did form a security association. Let me have to find it real quick. There you go, 3.0 to 2.0. And you see current peer is 201.2.50. But you'll notice there's no security association to the to ASA3. I just scroll up a little bit. Wait for it. Be easier if I did it by peer, right? You can see we get packets decaps, nothing in caps. However, if I just do a simple ping to 2.10, that's the VPC behind ASA2, pings will start passing. And traffic works. The problem is as soon as that session times out, you have to do the same thing over again, which doesn't scale very well, and it's super frustrating. However, if we come over here, we'll just do clear crypto IPsec SA. I'll make sure that it actually got cleared out, so I'll do a show crypto IPsec SA over here. Yep, that's down. If we take a look on our spokes, look at our access lists. We'll just delete this line, and then I'll add a line in, and we'll just do to just the IP. You could do this in an object group and make it look cleaner, but all of our sites begin with 192.168, so we just do 192.168/16, and we'll delete this top line also. Right? So that looks good, and we do the same over on 3. Delete that line, and then say site 3 to any 192.168 address is interesting to us. We'll just pop out that top line. That looks good. Now watch how much better this works now, right? Before, I would have to have both sites try and talk to one another for that tunnel to come up. Now, if I just do, actually, I think I can ping just a 3.10. Lies. Let's bring the tunnel up first by pinging up to the hub. All right, so I haven't tried to ping site 2 from site 3 yet, right? So before, this wouldn't have worked. Boom, and it comes right up. And the reason being, if you look at the security associations now, we'll do show crypto IPsec SA for 201.2.50. Helps if you type the command right. You'll see that now we're building it from this whole /16 as our local identity, and the remote identity is 192.168.2.0. So there's already a security association covering that, and likewise, whenever 3's tunnel comes up, it does the same thing. So we already have a valid security association for that whole /16 with the remote identity being 192.168.3.0. So now the spokes just have to come up and try and send some traffic to the hub, and as soon as that tunnel comes up, they have access to all remote sites. So if we brought another ASA on, we don't have to modify our access lists or anything on the spokes. And likewise, you saw there's no interesting traffic access list set up on the hub, which is the beautiful part about it, right? So one more time, show run crypto dynamic map and map. You'll see there's nothing static in here whatsoever for this communication to happen. So that's about it. Should be a relatively short video. In the next couple videos, I'm going to keep doing these site-to-site VPN sort of videos, but I'll do some iOS-based ones next. I want to do a Flex VPN for site-to-site purposes. And then in the Flex VPN series, I'll also cover how to do NHRP with Flex VPN, so you can build dynamic spoke-to-spoke tunnels, kind of like DM VPN. But for now, that is all, my friends. See you next time.